So you can find these three things. Graphing it becomes easy peasy, piece of cake. So let's do the x-intercept. For x-intercepts, guys, we know that we plug 0 into the y. So that's what we're going to do. We're going to plug 0 into the f of x here. And we have x plus 2. And then we have x minus 1. And then x minus 4. It's already factored for you. Sometimes these problems are not factored for you. This one is. Oops, I totally wrote that in the wrong spot, did I? Yeah, I did. Okay. Let's fix that. That goes up there. Boom. Okay, so this is for our x-intercepts. Now, because it's already factored, your job is only to look at each of these factors and say, okay, what number can I plug into all of these x's that would make this factor 0? -2. If I plugged in -2 to that one, to that one, to that one, I would get a 0 for this first factor, and then 0 times whatever I get for these would equal 0, right? Because 0 times anything is 0. Right? Yeah. All right. So what number, what x value would make this second factor 0? 1. So if I plugged 1 into each of these x's, I would get a 0 for this middle factor, and 0 times all these things would make 0. So it works. All right, what about the last one? Yeah, 4. I think you get the picture. Okay, so you just take each of those factors, set them equal to 0 to find your x values that would make that would be your x-intercepts. Okay, so that's those are your x-intercepts. Now let's look over at the y-intercepts. For the y-intercepts, you plug 0 into the x, and so that's what we're going to do. I'm going to plug 0 to the x, so let's do it. We have, and by the way, these are not multiplying to each other. This only means I'm plugging 0 into the x. That's all that means. So I'm going to plug 0 into all those x's, so I get 0 plus 2, and then I get 0 minus 1, and then I get 0 minus 4. That's just a 2. That's a -1. That's a -4. Now multiply all these dudes together, I get positive 4 times 2 is 8. That's it. This is your y-intercept. I could write it as a point too. I can say 0, 8. There's only one of them, so I don't mind doing that. But I don't want to do it for all these ones. There's 3 of them. That's 3 points. It'd be -2, 0, 1, 0, 4, 0. Okay, so we have all these intercepts. Dang! Okay, let's see. Let's do our x-intercepts. We have -2, 1, 2, -2. And then we have a 1, 1. Then we have a 4, 2, 3, 4. All right, so we have all our x-intercepts on there. And we have one y-intercept, which is at 8. So 0, 8. I'm going to say 1, 3, 5, 6, 7, 8. I'm going to put my 8 right there. I love drawing my own x and y axis because then I can scale it the way I want. All right, and then end behavior. Well, let's see here. If I were to multiply all this out, which I'm not going to because that would take a lot of time, I would have a degree of what? What would my degree be?
3.
Yeah. My degree would be 3. Actually, I should write degree because sometimes D means domain. Degree, I'm going to write 3. Okay. All right. Now, is it a positive or negative leading coefficient when I'm done? Because I'm trying to figure out, does the end behavior go down then up, or does it go up then down? All right. This is important to note. Okay, is it going to be positive or negative leading coefficient? Positive. That means, are we going to be the n or the upside down n? Yes, and so our end behavior, now this is good practice, as x approaches negative infinity, that's the left side of the graph, and as x approaches positive infinity, that's the right side of the graph, what is f of x doing? Okay, so I'm just writing it out, practicing our notation. Okay, left side of the graph, guys, what's it doing? Is it going to positive infinity or negative infinity? It is going to negative infinity, so we're going to put negative infinity. That means down. And then the right side of the graph, what's it going towards? Positive infinity, which means up. Okay, so for my graph, I like to go like this. Okay, from on the left side. Oh man, these things are in my way. I have to make these dudes smaller. Hold on. I'll make these guys a little smaller. Weak. Okay, out of my way. All right, so I'm going to put end behavior corner right there, and end behavior corner right there. That's just my style. You don't have to do it. And then I'm going to start drawing my line. Oh, snap. Do I go through all of these, or do I bounce off of any of those? Bounce? Which ones do I bounce off of? Okay, you go through all of these because their multiplicities are 1. They're odd. All of them only have a 1 right here, which you don't have to write. Like, if this one, you guys said bounce off a 1. If this said 2 right here, or if this said 4 right here, or if this said 6 right here, or if this said 8 right here, you guys get the point? If it's even, then you're going to bounce off of that 0. But all of these have an odd multiplicity, so you're going to go through each of them. I'm going to, let's see, what should I do? Should I do a T on each of these so I know I go through? Or you can do an X, I don't know. So let's go. Shebang, shebang, boom, boom. Done. And I was able to hit all my points. Notice I don't have any extra X intercepts, no extra Y intercepts, nothing like that. That one's done. Okay, since I know the multiplicity is the hardest thing to remember when it comes to this stuff, let's talk about this one really quick. All right, this one has 3 zeros, but they all have different multiplicities. Okay, check it out. Okay, I'm just going to graph them really fast. I'm not going to find the Y intercepts right now. We have X equals 1, -3, and then +2. 1 comes from that guy, -3 comes from that guy, and 2 comes from that guy. They all have a different multiplicity. Now, just like what I told you, Ashlyn, I always think of x squared. Now, x squared, I know what x squared looks like. I spent a lot of time with this guy. He just goes like this. Okay? In fact, what are the zeros for this guy? It's just 0, because 0 would make this 0. And so, right here at 0, we are bouncing off of the x-axis. Well, what multiplicity does a 0 have? It has a 2. So if we have an even multiplicity, we're going to bounce. All right, well, let's put these dots right here on our graph. So we have -3 is going to be our first guy. 1, 2, 3. At -3, I'm going to put a point. And then we have 1 right there. And then we have 2 right there. Okay, so am I going to bounce or go through the -3? Let's see. Has a multiplicity of 1. You see I don't see it right there. I could write it in there. He's the ninja. Boom. I see you, ninja. Okay, so we're going to go through that guy because it's odd. The multiplicity is odd. And then for 1, what am I going to do? 1 goes right there. Yeah, we're bouncing off that guy. He gets a B because I know, like, I need to make sure I know the bounce off of that one. And then what about this 2? 2. Oh, yeah, that's odd. Oh, and not just odd. It has it's higher than 1. That means we're going to do a little squiggly go through. Okay, funky donkey. So this is how it looks. I'm going to go through. Oh, wait. End behavior is 1, 2, 3, 4, 5, 6. Okay, all I did was count up the exponents. So end behavior is 6. That means we're going to go up because it's positive. The leading coefficient is positive. All right, so we were going to go through this guy. And then I'm going to bounce off this 1. And then I'm going to go through the 2. So that's how you would do that. And actually, whatever I get from my y-intercept would help me out with this y-intercept right here too. I don't know what this is, but I should get a negative number after I plug in 0 to all of these.